Hello guys, today we're going to go over 6.3 and 6.4. For 6.3, we only need to look at example 6, which is a little tricky. For 6.4, it's just transformations. I'm going to go over one of every single rule, and that's it. We're not going to review it anymore, because it's the exact same rule that applies to every other function. But we will review one of each rule. Now, for the inverse, in the previous class, we used the inverse property to cancel out the exact same exponents and log bases. Okay, that was the inverse property. Now they're giving you a function and they're asking you to find the inverse. And that was with the whole switch the x and the y's and then isolate your y's. Now it's a little tricky with exponents and logarithms. You'll see why. Now, for example, in the first case, let's go over this example. By definition, if they give you a straight up exponential function or a straight up logarithmic function, nothing else needs to be done. Just transform it how we have been doing it previously from exponential to logarithmic and vice versa. The only thing we have to keep in mind is, since they're not giving me exact values but a function, I have to do the whole flipping of the x's and the y's. Let's go ahead and do this example, and note that all examples happen like this. Again, you always change your fx for y. Next, you flip your x's and your y's. And now we do the exact same formula for conversion we've always done. The base of the exponent becomes the base of the log, and then the letters are flipped. The y is on this side, it now ends here. The x is on this side, it now ends here. And you leave it like that. If you want to, just leave it like that. There's no need to isolate any further. Leave it like that. And that's the answer. Again, flip your y's, change your f of x for y's, flip your x's and your y's, and then go ahead and just by definition, the base becomes the base, and the lines flip. Just in case, let's go ahead and do the inverse of this to see if I end up with the exact same function. I begin with this. I don't have to change my f of x for y because I have y. Now let's flip the x's and the y's. I have log base 6 x equals y. And now the base of the log becomes the base of the exponent. And the letter that's here comes to the other side, and this comes over here. I forgot to change my x's. Oh, actually I did. And that's pretty much it. Okay. That's pretty much it. So you just flip the x's and the y's and do the definition. Most of the time you probably won't get them like this. You might get one or two, but that's it. This is the more important case that you need to work on, and I'm going to do a couple of them like this and a couple of the original ones. Now here, they already gave me a y, so I don't have to switch my f of x. Step 2, change my x's and my y's. Now here's where it becomes tricky. When they give you a log, to get rid of that log, you have to make it an exponent. You have to, it's called exponentiation. Instead of multiplying, you make it an exponent with the base here, the same base as the log, to cancel it out. So in this case, what is the base of natural log? It's the letter e. So I'm going to exponentiate this side by e as a base, and I also have to do it on the left hand side. I raised both sides as exponents with a base e. I exponentiated my expression, and it's the exact same thing. You can test this with numbers, okay? Actually, let's go ahead and show you guys. 2x equals 4. 2x equals 4. In this case, my x is 2. Let's exponentiate both sides by 3. Let's see if it's still true. 3 to the 4th power. 3 times 3, 9 times 3, 27 times 3, 81. And If I change this to a 2, it's going to become 3 to the 4th power. The same thing I have here, which is also 81. So again, to get rid of this natural log that has a base e, I have to raise both sides with an e base. Now what's going to happen? This cancels this out and I'm left with this particular expression. This comes down. And in order to isolate my y, now you do normal isolation, -3. Note that my x is an exponent, but the -3 is applied to the e. It doesn't come magically up here as an exponent. You just isolate as normal. And that's that. Now let's say instead of natural log, they gave me a different log. Let's say they say log base 2. Okay, log base 2. What do I do now? You erase everything with a base 2. And it's the exact same problem, only the numbers changed. This 2 cancels out the log, and I'm left with 2y equals x plus 3. Oh, I forgot to flip. You have to flip them. And now you isolate. So again, the only thing that changes is the base that you're given, but it's the exact same process. You're always going to raise it as an exponent using the base that the logarithm has. Let's give you guys another example. And again, I'm going to complicate it a little bit. Let's say they give you y equals log x plus 10. Flip, x equals log y plus 10. This is a common log. It has a base 10. You're going to raise everything with a base 10. This cancels out and you're left with 10x equals y plus 10 minus 10 minus 10, and you're done. Now let me go ahead and do a couple of examples that are in the book. For example 6, I'm going to do, on the monitoring progress, I'm going to do 17 and 18. So 17, let's find the inverse of this. Flip your letters. By definition, normal exponent, this becomes the base of the log. This letter's on this side, it ends up over here. This letter's on the right hand side, it ends up at the left hand side. This letter's on the left hand side, it ends up on the other side. Okay, that's all you have to do, pretty much. Oh, one thing. Let me just rewrite that expression. I'm going to change my x's and my y's. Now, I'm going to put the log here. This y, which is on this side, comes over here. The x, which is on this side, comes over here. Okay, I just wrote it incorrectly because I wrote the log on the left-hand side previously. Again, you put the log wherever the base is and you flip the letters from the equal sign, and you're done. Let's go over 18. Find the inverse of this. Again, pretty straightforward. Flip your x's and your y's. This is a base e, natural log. So I'm going to raise this side to the power e, raise this side to the power e, y minus 5. This cancels out. I'm left with ex. Now this, even though it was an exponent, it comes down as the answer, y minus 5. To isolate y, I add 5, and you're left with the expression, and you're done. Now let's go over, and that's it for 6.3. To find the inverse, flip the letters and then just isolate. Now let's go over 6.4, then we're going to finish with homework. If you look at page 318, they give you the rules for the exponent transformations. And if you look at 320, they give you the rules for the logarithm transformations. And again, it's the exact same thing. When the minus is applied directly to the x, it's left or right in the opposite direction. This would be 3 units to the right. This would be 3 units to the left, because the positive and negative was applied directly to the x. This is exponents, of course. Now, when it's applied to the term, this would be 3 units up. This would be 3 units down. So that takes care of left, right, up, or down when we're dealing with exponential functions. Now let's go over let's go over reflections. When applied directly to the x, it's reflection across the y. When it's applied to the term, it's reflection across the x. Just like every other parent function. And also horizontals. When a value is multiplying my x, it's a horizontal transformation. If it's bigger than 1, it's a horizontal shrink. If it's between 0 and 1, it's a horizontal stretch. If these values are applied to the term, it's vertical, but the opposite. Just like every other parent function since we saw from the first day of class. Bigger than 1, vertical stretch. Smaller than 1, vertical shrink. That takes care of all transformations for exponents. Now let's work with logarithms. Pretty much identical. The difference is parentheses or no. When I have a parentheses, that means it's applied directly to my x. So this would be 4 units to the right. This would be 4 units to the left. If I get rid of my parentheses, that plus 4 or minus 4 is now applied to the entire term. So this would be 4 units down. This would be 4 units up. If you put a parentheses with a negative here, as every other parent function, a negative applied directly to my x is a reflection across the y. A negative applied to my term, whether I have a parentheses or not here, doesn't matter. It's a reflection across the x. So I'm going to be reflecting downward. If my log used to look this way, it's going to look this way. Reflected across the x. And if it's a reflection across the y, if it looked like this, now it would look like this. Seagull. There's a biology class as well. Now, keep on dropping my markers. Now that takes care of reflections. Now we're going to go over, again, applied directly to the x. This would be horizontal. Bigger than 1, horizontal shrink. Smaller than 1, horizontal stretch. Apply to my term. Again, could have a parentheses or not. Doesn't really matter. Bigger than 1, vertical stretch. Between 0 and 1, vertical shrink. For example, 0.3. And that's it for transformations. Now note, I probably will not be including transformations in the test. I might include a little bit, I'll let you know. For homework, go ahead and do the following. From page 315, please do from 43 to 52. Now, these are a lot of problems. If you know how to do them, they should take you a very small amount of time. If you do have trouble, it will take you longer. But the important part is that this is a very important section of 6.3 to focus on, finding the inverse functions. So if you have any problems, let me know. We'll set up a video call. Otherwise, that's the class. There is no homework from transformations. I think we're all tired of transformations. We've seen them so much. So this is the homework. Make sure you upload it. Please, I want to know if both sections have class on Friday. If both sections have class on Friday, we will give the quiz during class time. Okay? If both sections do not have class on Friday, we'll move it to Monday. We will be reviewing Wednesday and Thursday. Whether you have class or not, we will be reviewing Wednesday or Thursday. If both sections have class on Friday, we'll do test on Friday. If not, we'll move the test to Monday. That's going to give you the weekend to study. Besides that, if you have any questions about today's class, you can let me know. We'll set up a video call. It's a little tricky, but just take it one step at a time and you'll be fine. Have a great day. I'll see you tomorrow.